Hey guys, it is me, Chad, here with the Electric Academy. Let me just call up my camera here. This is going to be a quick one because I want to get this done. I said I would do it tonight, so I wanted to get it done, and my family's coming home right now, so I better get cracking. I had somebody ask me what the difference between a Y system and a delta system was. So I put together just a little quick PowerPoint, I guess you could call it, and I'm going to run over some of the advantages and disadvantages. This is by no means like the 100%. This is how it all works. This is just how it's just like a broad overview of how it works. We're not going to get into the math or anything like that. I've got those videos lined up for later. Those ones I'm going to be doing through my Electric Academy site. This time I'm just going to be doing something through just a quick overview of what the delta and the Y system is, because we all have heard about three-phase, but we all just don't generally, not all of us have an understanding of what it is. So let me just call it up here. Go like that. Go to here. Okay, play from start. So here we go, the Y versus delta. So I've got my Y system here, and one of the reasons why we can tell it's a Y is, funny enough, it looks like a Y. These are my transformers, or my windings, you could call them, and it looks like a Y. Over here they have the delta system, and it's the reason why they call it delta is it's shaped like the Greek symbol delta. Aside from that, that's basically the only reason why I can understand why they call it delta. Looked into it, and that's what I came up with. Y systems, some advantages of the Y systems. I got some notes here. First off, you have three lines. You have this line here, line 1, line 2, line 3. I should have named those 1, 2, or 3, or A, B, and C. I have these windings. Each winding is 120 degrees out of phase with the other winding. All right, so they're 120 degrees difference, and that's big. Now, when we're dealing with these, that tells us that we have two different voltages available to us with a Y system, okay? Now, I know a lot of you guys have got this theory down pat, but again, this is just a broad overview, so don't sit there and go crazy if I get something a little off here. Now, we have the nice advantage of having the Y system is this neutral. It allows us to have two different voltages, because we can have our line-to-line voltage, just like we have when we have a center-tapped single-phase system. We have our line-to-line voltage, but then we also have a line-to-neutral voltage. Now, if this is a single-phase system, and this is 120 volts, and this is 120 volts, my line-to-line voltage would be 120 volts, right? That's fairly obvious. However, because these are 120 degrees separated from each other, you can't just add these guys up. You have to add them up vectorially, not arithmetically, is what I tell my students. So I would have to take this guy and say, okay, it's 120 volts at, you could say, negative 30 degrees plus 120 volts at 90 degrees to get your line-to-line voltage, which works out to be, in this case, if you have 120 and 120, it's 208. So you have 208 volts. Sound familiar? You have 208 volts. So some advantages of this. Let me just actually move on to the next slide here. Now, when we're dealing with this, you have your E line, which is line-to-line, is equal to root 3 times E phase. That's a quick way of working it out. Instead of having to do all that trigonometry, you can just use the root 3, which is 1.732, times that by the E phase, which is 120, and that's where we get our 208 from. Now our current, again, just to say this, 120 vectorially with 120 gives us 208. Our current, however, is going to be in series with this, and current in series doesn't change. So our I line equals our I phase. Now this adds to, let's talk about some advantages. I got my notes here. Some advantages of Y. Now you can have two voltages, which is nice. You can bring three-phase in, and you can have single-phase available to you. There's that. You have your neutral point, which is generally grounded. I should have put a ground on here, but that star point, sometimes it's called a star point, is grounded. It's good for unbalanced loads. It requires less number of turns than the delta type because you have a lower voltage here. You're using this voltage plus this voltage instead of having one winding having to carry all the line voltage. And you have less insulation too because this voltage is going to be lower, but you can still get the 208 safely out of that. So it's very, very useful that way. And you see them a lot on the, if you have a delta Y system, they use this to get the two voltages out of it. Very common in buildings, commercial and industrial, you'll see that. Some of the disadvantages are if you've got a Y connected motor, you get less torque out of it, and it's a little more expensive. So that's your Y connection. Now this could be for distribution, and you notice I've got the coils here, or you could have it set up as a load. I could have had to have a resistor load here. You can have load set up in Y as well. Again, this is just a quick overview. I could go on forever and ever about this. Now, this is the delta system. The delta system is a bit different than the Y in the fact that you don't, if you notice, line to line here is just across a phase. So your line and your phase voltage are the same voltage. So if this is 120 volts, your line to line is 120 volts. So there's that. The difference is your currents, because if you have your currents here, you could have your phase current coming up to this point and this phase current coming up to this point, and they meet at a node and then they go into the line. That's where you have to use that root 3, because again, we have to add them vectorially, because you can't just say this guy plus this guy equals your current. You got this guy coming in at an angle, this guy coming in hot at another angle, so you're going to get a different current. So if we look at this here, your E line equals E phase, which is very true. It's your current that changes. Now, some of the advantages for a delta system is the motor torque. It's got high motor torque. It can handle it because it's got a higher current it can handle. It's more efficient. The protection is generally fairly simple. They're set up for heavy-duty applications. They're great for transmissions. You'll often see them set up as a delta Y transformer. When you are sending them across lines for transmission, they prefer to have the delta configuration, even though the current might be a little higher, because you only require 3 wires. Now, you can get the high leg. When you talk about the high leg delta, you can actually tap this and ground it and have 2 voltages. You'd actually have 3 voltages present. Again, I'm not going to get into that. That'll be another voltage or another video for another day. The disadvantage to this guy, though, is it has no neutral. So it's just line to line. You can't get 2 voltages out of this generally. You can, like I said, with that high leg one, but we're not going to talk about that. Another downside to this is that ground faults are really difficult to detect because you don't have that grounded point. So they can be a bit of a nightmare to work on. Anybody that's worked in the plant knows that you have a ground fault detection system that just indicates which phase it's on. Then you got to go looking for it. I've done that. I've spent days trying to track down ground faults in a plant that I worked at, a styrofoam manufacturing plant, in fact. What else? They're really useful for distribution for that reason, because you have 3 wires, not 4, so you save some money on that. Let's just see if I've covered all my notes here. Some motors, just as a note, they'll have these soft starters. So they're going to start a motor, they'll start it in Y, and then they'll move it up to delta, because you've got a lower current in Y and a higher current in delta. So they call them soft starts, a Y delta soft starter. Again, maybe I'll do a video on Y delta soft starters later on in the year here. So that's just generally basically just a quick overview of what they do and what the systems are. Again, the difference generally is just the shape and the way they're set up. The Y has got that neutral into it, so it makes it very useful. You can have 2 different voltages out of that. It's generally going to be on the secondary of your transformer. The primary will generally be a delta. Now, I'm not saying there's not a Y delta transformer. It's just more common to see a delta Y configuration of a transformer. And I think that's about all I wanted to really touch on today. Yeah, so hopefully you guys got something out of this. I'm just going to get rid of this guy right here. Let's just escape him. And I'm going to call the video up here. So hopefully that helped you guys. Hopefully I answered, I can't remember, I think it was Anthony that asked the question. Hopefully, I know it was really not a ton of information, just kind of a light skim over of the difference between Y and delta. If there's anything else you guys want, let me know. If you're wanting me to do a more in-depth one on this, like getting into the math and all that, let me know, because I do plan on building one of this. But if there is a demand for it, I will build a proper one like I do. If you go to my YouTube channel, I've built a ton of them on there. So if you go to my YouTube channel, you'll see the kind of work I've done before. If you want something more in-depth on 3-phase, like behind the math and hookups and all that, I can do a whole 3-phase series, because that's what it would take. This is just, once again, just a brief overview of that. Make sure you stop by the site. Check out www.theelectricacademy.com. Make sure you sign up for the newsletter. I send one out every Wednesday, and it just keeps you guys in the know of what's going on with the Electric Academy, things that are coming up, articles. If I've got some blog entries that are doing well, I usually post them on there as well. Hey, thanks, Tim and Josh. Good to see you guys. And just keep the requests coming. I've been loving this. It's been so great. I've been talking to tons of you guys through email. And how do you check any kind of industrial motor? That's a great question one. There's another one that goes into the bank then. So we'll have to talk about that. Yeah, I'm going to put that on my list right now before I forget, just so you guys can see that I actually do write this stuff down. I have been having a blast interacting with you guys. Keep the emails coming, please. Keep the direct messages coming, please. I love talking to you guys. I love helping you out. I love doing all the research on this. I've learned some stuff just on this one. I work a bit with the three-phase stuff, but I don't teach it a lot yet. So it's good to kind of brush up on that. So please keep those coming. I really appreciate all the feedback. Hopefully you guys are having a great day. I'm having a fantastic day, getting ready to start coaching my son's soccer team. I talked to my co-coach. He's 5 years old, so that should be interesting. My 14-year-old starts hockey tomorrow, so it's going to be very busy this fall, but that's why we're in it. We love it as parents. Okay, have a great night, guys. I will have probably another one of these. I'll probably do another one on maybe a quick one tomorrow as well. Maybe not something so technical, maybe just more of a rant. I got something lined up. You're going to love it. I know I did. All right. Hope you guys are working safe. And yes, I definitely will, Juan. Make sure you join the Facebook group at least, or join the newsletter. Just go to theelectricacademy.com and join that newsletter, man. And then you'll know when they're coming up. I'll start scheduling these a little more and let you know what's happening and what I've got lined up, because I think that'd be a bit more interesting and useful to you guys. You work for the government. I gotta go. Just kidding. Canadian or American, I guess would be the question. I'm Canadian, but that doesn't mean I don't know about the American government. So we'll see. Good luck to all you guys down in Florida. Holy man, that is quite some storm we got coming your way. So please stay safe. And you guys who are out on the field, stay safe. Juan, I'll be in touch. And make sure you hook up with me on Facebook. Send me a message about more what you want to know. And I'll go with that. All right, guys, have a great night. This has been fun, and work safe.